Okay, so if x1 is the amount of alloy A and x2 is the amount of B to produce alloy C, what would be the cost in producing alloy C?
x1 plus 2x2.
x1 plus
2x2.
x1 plus alloy B cost plus 2x2. So cost will have, okay, is this the, what is missing here in this? I mean, these are in, for example, let's say in kgs or percentages. Okay, so this cost would be something in terms of, I mean, some factor k would come here, means cost per kg. So that some amount will be there, but we'll ignore that because our objective function mathematically it doesn't make difference that k is there or not there. Our optimization would remain same. So this becomes our objective function. So do all of you agree with that? Yeah. Okay. So we reach the objective function and we have got uh, the design variables. Okay. So now what needs to be done is to write the constraints in terms of the data which is available to you. So what
So,
would
it says that alloy B costs twice as much as alloy A. That means the equation is x2 is equal to 2 times of x1, right?
yeah means if the cost of x1 is k times x1, the cost of B would be 2k times x2. So the total cost of producing the C would be cost of A plus cost of B. So that has been written here. K is not written here. K is the unit cost of alloy 1, alloy A.
Okay, sir.
I'll I'll repeat once again for others who all similar doubt that if cost per unit kg or unit percent of x1 is k, that of B would be twice of k. So total cost of x1 amount will be k times x1. Total cost of second alloy will be 2k times x2. So total cost will be x1 plus 2x2 multiplied by k. But objective function means it is just a set of parallel lines. So that k doesn't count here. So we can simply say objective function is x1 plus 2 times x2.
Okay, so they were talking about per kg rate here, the 2k, 2 times the rate.
Yes. Alloy B costs twice as much as twice A. Yeah, rate will be in terms of per kg. Yes, rupees per kg. That's right. So what, how would you write the constants? Okay, so can you define the constraint? Similar to others. Okay, let me see what. Okay, Ganesh, I did not see your first line. So 80x1 plus 60x2 should be greater than or equal to 65. Greater than or equal to 65. I will just take one phone call.
Why did you not multiply 2 into x2? Sir, you are on mute.
Yeah. So let's understand what does that physically means. 80x1 plus 60x2. So what Ganesh is saying is this column. So for A, we have taken x1 amount, B, we have taken x2 amount, and he has written A would contain, x1 would contain, means out of 100, 80 component, or one can also say 0.8 x1. So this also can be written as 0.8 x1 plus 0.6 x2 should be greater than or equal to 0.65. Okay, so do others agree with this? Similar to others is means Ganesh has given his answer. So anybody has any other thoughts on that? So out of alloy A, which is x1 as a fraction, if you are taking, it will have zero point 0.8 times x1 amount of copper. Similarly, when you are taking x2 as a fraction of alloy B, you will have 6.6 times x2 as the amount of copper there. So if you add these two together, that should be more than 0.65. That's what uh, it's been saying. So anybody has any doubt, question on that?
No, sir.
Yeah. So tell me the other equations. So I'm just dividing by 100 so that we get equations which are more, means in graphical method, smaller is better, means smaller is better to plot. Plus zero point 0.6 x2 should be greater than or equal to 0.65. Okay, what would be the equation for zinc?
Point 1 x1 plus point 2 x2 greater than or equal to 15.
Greater than or equal to 0.15. For lead, Let somebody else tell
0.
other than, yeah,
Yes, sir.
yeah. 0. 0.0.
0.06 x1 plus 0.18 x2 should be greater than equal to 0.16.
Okay. The last one. Somebody else.
So
Zero point
0.04 x1 plus 0.02 x2 should be greater than equal to 0.03.
Should be
So
greater
I
than
find
0.0.
out,
Yeah,
so the 2 that we multiplied in objective function with x2, since
right.
for the cost thing, so we won't be considering that while writing constraints.
No, this is what we are trying to minimize. So we have to find out how much x1 should be there, how much x2 should be there in order to, which will minimize the cost.
Okay.
So when somebody, let's say, wants to take zero amount of B and 100% of A, then you will get 80% copper, which satisfies. But you will get only 10% zinc, which doesn't satisfy. So you have to add some amount of B. So how much you have to add? So you have to find out the balance between the two. As you start adding, so the proportions will keep on changing. So this 4 becomes your constant equation. This becomes your objective function. Now, if you remember in the classroom graphical method that we talked about, you have to plot, means this method is applicable to only problems of two dimensions. Means 3 dimension you can do that, but you require maybe CAD software for that. But 2 dimension, and we are having two variables, x1 and x2. So the way this method works is you have to make one axis as x1, another as x2, and we have to plot all the constant equations. So this is first constant, this is second, this is maybe third, and we have to find out which is the feasible region. So this, for example, we are if I plot the 4 constants, and these are the 4 constant lines. So here we are talking about greater than or equal to, which means that we are looking at the region which is beyond this. So if this is the line, then the region that is feasible is this one. For second line, it is this one. So what we are looking at is the region which is this. The region which is beyond all the lines is the one which is feasible. Yes, of course, I think you have to go beyond all the lines. So which means that the feasible region in this case, that arbitrary thing what are drawn would be, let me use another color. That yellow color what are drawn is not correct. So the feasible region for the random lines that are drawn would be this one, which is beyond outside all the things, because we want uh, this numbers to be greater than or equal to. So which means they will lie on the away from the origin side. So this is the region, and in this region, whatever polygon we get, we have seen in the classroom that for linear programming problem, each the vertices of this polygonal boundary that we get. So one of the vertex is the optimal point. So we have to find out which. So one way is to find out which vertex, at each of the vertex we can calculate what is the value of objective function, and whichever is minimum we can calculate that. Or more polished way or more elegant way would be to plot the loci of this objective function. So we know this objective function x1 plus 2x2. So that would be a line which is like this. So the objective function would be moving in this particular pattern as the cost increases. So this is more and more cost. So we have to find out first vertex which passes through this objective function line. So that would be our solution. Now this would require plotting this. So if you have graph paper with you, then you can, means in the exam scenario, in the offline exam scenario, you would be having the graph paper with you, and using that you can plot these lines and find out which is the solution. Now, since we are in the online mode, we will use the online tool. So I have given one link to GeoGebra um, site. So if you go to geogebra.org/calculator, you will get this particular uh, software. So this will allow us to plot our constraint equations and solve this problem, or at least visualize our problem. So which how is the shape function, how is the our constraint space, and which vertex would be feasible point. So to do that, I have just given how to plot a line. So this I will not be able to write here, but here that uh, violet color thing. So a colon x plus y is the just arbitrary some equation I have given. So there you have to put actual equations. So let's put our constraint equations there. So I will first draw all the constraint equations. So we'll have that polygonal boundary which we want to plot. So what is our first constraint equation? I don't have, because I'm using the tablet. So that is my screen is below this, so I cannot see it. So can somebody tell what is the first constraint equation?
0.8 x1 plus 0.8 x1
Okay.
plus 0.6 x2.
So here instead of x1 and x2, I am writing x and y. Just they are the default variables in GeoGebra. It may be able to handle x1, x2, but I did not explore that. You can do that. And what is the constraint?
It's greater than or equal to 0.65.
0.65. So here, whichever, if it is a less than, then it will shade the region which is towards the origin. So I'm shading the region which is not feasible, so that whatever white space we see is the feasible. Let me hide this red color line. So this is our first constraint. So 0.8x plus, so x is x1, 0.6y, which is x2, should be our constraint is should be greater than or equal to 0.65. So instead of greater than or equal to, I just made it less than or equal to, so that less than or equal to becomes shaded. So that shaded region, our solution doesn't lie. So whatever you see that as a blue colored zone, so that is non-feasible zone. So white zone is the feasible. Okay, so like this, we have to write the 4 constraint equation. That is what I want you to do. I hope you have access to either laptop or tablet. On mobile, it would be very difficult to control this particular website unless you have very dexterous hands or fingers. Okay, so I want one of you to plot all the constraints and then share your screen to show it. I hope you are, at least few of you are having laptops with you. So can somebody confirm that you are working on this?
Yes, sir.
Okay, good.
Yes, sir.
You can add more constants using this plus sign. So you can add more equations there. And you can give them constraint names also. So instead of A, one can call them G1, G2 and all that. Okay, so Jay has plotted. So Jay, can you share your screen? I will stop sharing.
Yes, sir.
Okay, I'm sharing from another device. Sorry. Oh, that's good. Just zoom to the so that we can see the outline. Yeah, so Jay has made it very colorful. Just zoom it further so that we can see the outline. Okay, yeah, this is okay. Okay, so the white region is the only region which is feasible, and that is where we would be exploring. So now can somebody tell which could be the possible point which would be having minimum cost, or how would logically decide that? So here it would be helpful to plot the objective function or the pattern of objective function. So one can plot x plus 2y equal to k. So Jay, you just add one variable k equal to maybe 5 or 0 or something, whatever, and write
Okay,
another
sir.
function. Okay, he has already done that. Okay, so just write x plus 2y equal to k. Before that, you have to define k. So put k equal to anything, maybe 0 is also okay. And then put x plus 2y equal to k. Okay, and go to the properties of k, that three dot thing, and make it slider. Yeah, slider give range from some 0 to 5 or whatever. Yeah, so now if you vary that slider, you can see that line being plotted. Okay, so Jay has done nice job. So as the k is nothing but your profit, sorry, cost. So as the slider is going to the right, the cost is increasing. Okay, and our feasible region is anywhere in the white region. So which point would give you minimum cost? So looking at this graphical thing, can somebody tell?
Sir, it will be the intersection of curve B and C.
Curve B and C, that's right. So that is the optimal point which will give us the minimum cost. The remaining points all means looking at the trend of our objective function would always give higher cost. So minimum cost will be intersection of this. So you can either do that by solving those two simultaneous equations, or here graphically you can do that. Or you can do that. Okay, on the left hand side, there is something called as a tools. So if you go to tools, so there is a point option is there. Point A is there. So if you click on that point, it will select that point and again go back to algebra. So there the coordinates of A would be shown. So that is the solution. I can't read it from here. So you can just tell what is the value.
0.366, comma 0.769.
Okay, that means we require alloy 0.36 and remaining is the uh, amount of B, alloy B we require. You can cross check that by, of course, this will be, should be correct. But we can solve those two simultaneous equations corresponding to those constant lines and find out that it is so. That is the solution. Okay, any questions or doubt at this stage? So this is how it has to be done. If you are doing offline exam, then you would be provided with graph paper and you will be solving using that. Or if you are very good in imagination, without graph paper also you can visualize which lines, which intersection point you have to find out and solve it. Okay, any questions or doubt?
No, sir.
Okay, now we'll not exactly solve the problem using the Python code, but to just to initiate the use of Python. So the same thing what we plotted using GeoGebra, we will solve it or we'll plot it using the matplotlib Python library called as a matplotlib. So I already given the template code.
Sir,
So
should I stop sharing?
yeah, I will start sharing. Okay, so I lost.
So for the Matplotlib, the course that you had given, the IIT Bombay course, I went through it, just the two modules. But the thing is, it's very old. So the interpreter that we are using, the functions are not matching somehow, and it's asking for download the Matplotlib. So do you have any source, or you have downloaded for your interpreter or something?
Okay, so for this course, we'll be using what is Google Collaboratory. So it is a again web-based interface. So it is a cloud solution. So we'll be solving on Google server. So everything installed on the Google server. So we'll be just using Chrome browser or any browser interface to run now your program on Google servers, and it will give you the answers. So although it is happening remotely, but you will get as if a real life feel. Okay, so that training course IITB was more to get the basics of Python language. So once you get familiar with the basics of Python language, the templates which I'll be giving, they can be run using the Google Collaboratory. So let me just plot, means go to that. Only thing I'm not able to, okay, share the screen. Okay, to answer your question, that you're right. It is not old interface. It is command line interface, and yes, you have to install various libraries on your local machine in order to do that. Okay, so what you need to do is you have to in your browser, any browser, Chrome is since it is Google, Chrome will go very well, but any other browser will work as good. So you have to go to this path collab.research.google.com, and there it will open this interface. So this is known as notebook interface. So the advantage of this is here the your code and output, they all, both of them get saved in this particular format, what is known as IPYNB format, or IPython notebook. So IPYNB is IPython NB's notebook. So that format stores both your code, which is there in different cells. It could be in one cell as well, but it could be in different cells also, and the solution that you are obtaining. So all are available together. So what template I have given to you, it has all the libraries and other things loaded. So in order to load that template, first you have to go to collab.research.google.com. I think it will ask for you to log into your Gmail account, because it stores it can store these files to your Google Drive. If you don't store them, they will once the session is over, they will get lost. Okay, so once you go to this particular website, you can go to file, and you can whatever file I have shared through the classroom, the same file you can download, and then use this upload notebook interface to upload that particular file. So once you have the template, in the template I have given I think you may not be able to read this on the screen. So what I given is the structure by which you can create a plot as shown here below. So on the x-axis you are having the x1 variable, on y-axis we are having the y1 variable or x2 variable, and just one constraint line has been drawn there. So given constraint as we have seen there, so that is point at x1 plus zero point 0.6 x2 greater than or equal to 0.65 has been drawn there. So here it is only equation of the line. So there is no shading and all. That may be possible, but I don't know how to do it in this matplotlib. But that is not important. What I want you to do is just play with this code, and you should be able to plot uh, all the four constraints, and that will allow you to visualize any problem of this type, graphical problem of this type. And this technique will be useful in the subsequent sessions, because very important part of any optimization problem is the ability to visualize the problem, and this particular code or the snippet will allow you to plot any function. So right now we are plotting straight lines, but any other function can be plotted using the similar style. And it also allows you, means this code shows you how to give the labels to the axis, how to give labels to the curves, how to give title to the graph, how to control the size and aspect ratio of the graph, and so on. So I want you to start working. Even if you don't know Python, by common sense, you should be able to plot the 4 lines. So if this code is given to you, I think without knowing Python or without knowing what language this is written in, you should be able to plot the 4 lines. And later on, you can study each of these statements to understand what they are doing. So there is an excellent documentation for this matplotlib library, and it's very exhaustive. Means you can do much more than just plotting the lines, which will be useful to you later on. Means you don't have to read that documentation. Whatever is needed, just go through that, refer to that. Okay, so I want one of you to plot those 4 constraints and show it to me. One or more, as many of you as they want. I will stop sharing my screen because I don't think it is of much use. If you have any problem in loading this sheet, then for demonstration sake, I will keep it my screen open. So if you are facing any problem, just tell me so that I can demonstrate how to load the file and so on. So throughout this course, I will be using this IPYNB format for the code. It can be converted to the regular .py or Python file, that is a regular text file code. This format allows you to store the output, which is helpful, especially in this teaching learning scenario. So you can show me what is your output, and without losing it, you can email me the file and it will still hold the output, which is not possible in regular Python, which I have to run and then get the output.
Sir, in this code, why have we converted the whole equation into the form of one single variable?
I think there is no way otherwise I can plot the line. Means you can, the plot function, it requires 2 arrays. So first is X array, another is, means you require one array for one axis, another array for another axis. So which means that second variable has to be expressed in terms of first variable. There must be some way of doing it because not all functions will be separable in terms of X and Y. But at present, I know this method.
Okay, sir.
if you're already familiar with Python and if you know some other way or you're familiar with some other style of doing that, you can do as well. Means I'm just giving this template for some of you or most of you may be beginners. So it gives you some guideline as to how to write the code. So what code has given has been written by me. So it by no means best code, but it works and that is what matters.
Sir, I've plotted the constraints.
Okay, great. Can you just share that?
Yes, sir. So this is what I've got.
Yeah, that's right. It is similar to what I think Jay got in GeoGebra, except
Yes.
that this is not shaded. So we
Yes.
got still that solution point is same.
Yeah.
Yeah, that's good. Okay, so yeah. So as a means what you have to submit for this assignment is your solved GeoGebra file is with all the constraints and that intersection point and this particular code. So that is what. And if you can discover how to shade this particular graph, that is something you can tell me then. I don't know how to shade these graphs. Okay, but for completion of the assignment, you have to submit these two files, GeoGebra file and I mean, it's one scan sheet where you have written all the constraint equations. Means the problem formulation of the problem in terms of objective function, design variables and constraints. One PDF file, one GeoGebra file, and one this IPYNB file. Yeah, any questions? Okay, and what Alicia you asked in the beginning that IITB means you have to locally install that matplotlib library. So if it is not installed, then you have to use pip command. That's what pip command
Okay, so noted.
to install that. So how to install that? It's available on through Google. Means I also found it through Google only. Means I use pip command, but I've forgotten where that command line interface is handy some other times, but this is more convenient, the browser based. Only flaw here, if you don't have internet, you will not be able to use that. So for that, uh, you have to locally install this software. So there is for Windows or for any operating system, you have Anaconda as the software package, which is open source. So it will have then you can without internet also you can solve means IPYNB files you can use. Okay, Ganesh is using PyCharm. I have never used it, but yes, previously some of the students have shown me that. Yeah, that is the more modern interface or more better interface. So you can use anything that you are comfortable with. Okay, so if there are no questions, we'll stop here.